after our nice tour abroad. I guess I'll zero back in on Alberta and probably more specifically to Southern Alberta for a lot of what we cover with land classification. My name is alone on the title slide, but as I was working through this, I realized that over the years to get to the final product with the land classification systems involved a lot of different people, a lot of soil survey, federal and provincial people who've been involved with mapping and classification over a lot of years. One of those people happens to be here, Tom Jensen, who worked with land classification for quite a few years, where I first met Tom back in the 80s. So he's here to point out all the errors in my presentation and show you the right way that it should have been done. But it's good to see Tom here. Quick outline, a bit of the history of irrigated land classification in the province. We'll touch a bit on the legislation and where it falls within the province. I'm going to go over some of the basic classification processes. I'm not going to go into how we come up with all the final ratings and whatnot, because that's a whole talk on its own. This is just more what you would be collecting and what sorts of things are pulled in as far as information to come up with those ratings. Brief bit on who should be producing these land classification reports in the province, and finally the role that, I guess a little bit of history on our role and what our current role is with Alberta Agriculture in the whole land classification business. So a bit of history, but first a definition. This is right out of the book. The land classification is the systematic examination, description, appraisal, and grouping of land on the basis of physical and chemical characteristics affecting its suitability for sustained production under irrigated agriculture. The guy in the picture doesn't really care too much about that. He's farming as they did back in the early days of irrigation. Land classification became a part of our concern in 1915 when the Irrigation Districts Act was brought into effect. Initially, there was no soil looked at. Basically, if you could be like the guy in the previous slide and get water to your land, well, that was irrigable land. Anything below the ditch, anything that was full of gravity was considered to be something that could be irrigated. And this was used by the districts to, as a way of assessing the land that was within their area of control. Limited knowledge of Canadian soils at that point in time as well. How did they react under irrigation? There's still, pretty new in the province, and not a lot of knowledge of what would happen when you put that changing regime in place. This is an old map that was used basically to show where the irrigable areas were under gravity. If you look at this corner here, this arrow indicates where delivery would be, a high point in the land. The water would flow away. You can see these areas here are outlined a little better on this one with yellow. Those are high areas. Those would be considered non-irrigable pieces of land. The rest of it, you can get water to it, you're good to go. Didn't consider a lot of things such as problem soils or bedrock or gravel pits or things like that, although producers were able to make a case and say this land isn't irrigable because it was too wet or too salty, some things that were fairly obvious to the people using the land. Okay, so it was decided that after a while that the need to know something about soil was a good thing. So the first soil survey looking at irrigation specifically was done by Wyatt and Ward in 1930, and it was carried out in the Lethbridge Northern Irrigation District, and that's just north of Lethbridge here. It's a system that was intended to look at the productive capability of the soil, so it's based on a lot more of the physical characteristics, the texture, the organic matter, salinity characteristics, any erosion potential, stoniness, things like that were looked at. And so now it's moving away from just working to get the water to the land to what's the land that you're putting the water on. Some of the assessment tools that were used are still kind of interesting, though. As far as a topography assessment, the distance from a railway shipping point was considered. So I guess they felt that even if you can produce more crop, if you can't ship it anywhere, it's not as valuable a piece of land. And that also led into assessing the value of water on the farm. If it wasn't something that could be perhaps transported or made accessible for market, then it wasn't maybe a source where the water should go as quickly. Systems like this were used through the 30s and well into the 40s. Once you got into the 1950s, you started looking at assessment-based, a little bit in conjunction with Dryland Assessment systems. Different weightings were put on some of the factors like organic matter and texture. The organization formerly known as PFRA developed a system in the Bow River Irrigation District. One of the things they looked at initially was the probable net future income, which is, again, not really looking at soil characteristics, but they did adapt a handbook later into the early 60s that did look at soil characteristics and drainage of soil and the topography characteristics of the land as well. And they used this across the prairie provinces. About that time in the early 60s, the government of Alberta started to look at some of the irrigation works and determine any need for rehabilitation, because by this time a lot of these systems had been in place for the better part of 40 years, and they were starting to show issues with where they were constructed and just wearing out over the time. The construction methods obviously in those days were not quite the same as they are now. And a lot of this led to the new Irrigation Act being passed in 1968, and in conjunction with that act, the first actual set of irrigation classification standards was adopted for use in 1969 as a part of that act. So what this did was it entrenched the legal need for classification of land. So now it's the law and it must be carried out. However, there was a period of time in there where the districts, some did, some didn't, some, as long as they were looking at land at least as strictly or as rigorously as the Act said, then they were fine. They could be better or more rigorous if they wanted to. Less rigorous was not tolerated, I suppose you could say. But late in the 70s, the Irrigation Council decided that from this point on, any new land coming under irrigation did require a classification to be done with it. But they also recognized that since the first standards have been put in place in 1969, a lot of things have changed. You've gone from this style of irrigation dominantly at the flood, but now you're starting to get a lot more of the mechanical systems in and pivot systems in. So now instead of relying on gravity, you're now into pumping water. You have your topography limitations are much less now because you can roll wheels over a lot of different things and pivots. So the standards were re-examined to see if they're still appropriate and make any changes needed. So a lot of changes were made to them with the final land classes as well as the soil and topography categories that make up those land classes. This is just an example of the two maps. The one on the left is the system is based on the 68 to about 1983 standards, and then with the new standards that came in 1983 is the one on the right. A lot more information given strictly on the map here. You have a land class, you have the soil subgroup, you have parent material, and there's information on there as well as the chemistry. A lot of the topography ratings were based on the ability to convert this to a flood irrigation, a border dike kind of a system. So a lot of earth moving characteristics, and so there was obviously a lot of land that wasn't suitable for leveling and became something that would have fallen under a mechanical irrigation system. The one on the right is much cleaner looking. It just gives the basic land classes. There's a soil map that would be associated with that, that would provide the rest of the information for those land class units. And it just basically gave the land class. The irrigable areas are not cross-hatched. They're the white areas. The cross-hatched ones are considered non-irrigable units. And the topography now was much more simplified to show that there was a classification there, that if it was nice and able to be developed for flood irrigation, that's there, but it also acknowledged the fact that there's now a lot of side roll systems and other systems in place that make irrigation much more easy on a lot of different sources of land. Since that time, there's been three other additions to the land class standards, three changes. In 1990, what's called Class 5R was added. This is Class 5 is considered a non-irrigable classification, but with potential for improvement to an irrigable class. The R means that an improvement has been made and irrigation is being allowed on a temporary basis to see if it will be improved to an irrigable class at some point in time. The best example of that is seepage, perhaps due from an irrigation system or canal. And now the canal has been put into a buried pipeline. The source of the problem is gone, and irrigation on that land may help to leach salts down to a level where the land has become more productive now and would be considered irrigable. Another change in 1998 was to the solonetzic ratings. They were adapted to look more at the chemistry and the structure, as opposed to just previously, if there were solonetzic soils present, they were considered to be non-irrigable, pretty much out of hand. But now it was looked at and adjusted to consider the fact that there may just be structure there, relic structure. The chemistry is no longer as much of an issue. And in 1999, the bedrock and shallow gravel aspects of the standards were reconsidered as well. The most current version of the standards was completed in 2004, and that's what's pictured there. Both of those documents, the standards document here and the procedures manual here, are both available online. I would put the website up, but being it's up on the web, it's a long, ugly website. So if you go on and just Google land classification in Alberta, you'll be able to find those on there. So they're both available. Now a bit on the legislation. As I mentioned, it's come under a couple of different acts. Currently, it's under what's called the Irrigation Districts Act, and that came into law on May 1st, 2000. Within Section 94 of the Act and Section 4 of the General Regulations, that's where all the legalese around the requirement for land classification in the irrigation districts is found, and it covers a lot of other detail within there. Not only is land classification required within the irrigation districts according to the Act, irrigation outside of the districts, so now we're looking at things that would require a water license from environment, pumping out of creeks, rivers, other sources of water not provided by irrigation districts, are still considered to be needing a land classification, and that is a part of an ag feasibility report, which would be needed for the overall project as it was developed. This, again, as I say, is something that's taken care of by Alberta Environment Sustainable Resource Development, and this document is just recently revised in December of this past year, bringing it a little more up to date with some of the changes that have occurred as far as our land classification process. A third area where there could be irrigation is the use of wastewater irrigation, and they follow the same guidelines as well in saying that land classification is required. And so basically what it amounts to is within the province, if you're irrigating land, you're going to be required to produce a land classification report if you're bringing any new land into the process. So a little bit about the basic classification process. This is just an example of a completed land classification report. This is the classification map and the remarks page that goes with it. To get to that point, you start off essentially with, I would assume most people would want to do this anyways. This is the process we have in our manual as far as what's available for information is collect the background information on your site. By contacting our office, or myself in particular, we can provide you with a lot of background information. If you have the land location, we can provide you with imagery, any reports that may or may not have been done on that land. It's amazing how we'll get a consultant phoning us to get information on a parcel of land and find out that it's already been done. The person who bought the land from the previous owner perhaps didn't develop the irrigation but had the report done. New owner didn't realize it was even done, and he's lucky. He saved himself some money. He gets a report already done. But we can give any previous information, and we'd also include soil logs and chemistry that were associated with that land. We also have some larger scale, more large-scale planning land classification maps that have been done, such as this one. And again, any of that information would be available to consultants to further background information. It can save them some time in the field as well if there's already existing work been done. Once in the field, you're going to be doing the soil logs and describing according to the Canadian system of classification. Going to require some samples for analysis. The rating system, again, without going into detail on that, you're looking at basically three zones: the top half meter, bottom next half meter, and the third half meter. So you want samples from within each of those zones to reflect essentially the salinity and acidity parameters, but you may want to collect some for texture analysis as well. The samples are collected on a horizon basis, and I've emphasized this because it's a little ambiguous in the manual, and that's one of the things I want to change. You don't bulk it across the depth, you sample within the horizon. It doesn't do you a lot to analyze a sample from the first half meter to try and determine if it's a BNT if you've got your A and B and C in it. So you have to go by horizon with that in order to come up with a rating system. You do your field inspection at that point in time when you're out there, so you do a sufficient number of holes, and we'll talk a little bit more about that in a minute. Any topography ratings as well at that time. You can also use imagery and topography maps to come up with some of that information. Your samples are taken in. Routine analysis involves the parameters listed there. The main ones that are going to be affecting any of your rating is the EC and your SAR calculation. We look at those pretty closely as far as what effect that will have on the ratings. Too high, it's going to be non-irrigable, and then there's a variety of levels that it can be downgraded to modified. Particle size analysis and water holding capacity are also analysis that you may want to have done on some of the samples, depending if you have very heavy or very coarse soils. That will affect the final rating, and sometimes in the field it's difficult to determine just exactly where you are on the whole scale with those kinds of parameters. 4 minutes. 4 minutes? Okay. Intensity, there's 5 levels of intensity. We're just going to talk quickly about the one that's for water rights. So if you're going to go do a water right investigation and you go out in the field, you need to put in at least 10 sampling sites. Of those sites, you have to sample various ones to the 2 meter and 3 meter sites. So 4 of the 6 have to be logged and sampled as well. The remaining are inspection sites, which can be sampled as well. It's at the discretion of the classifier and depending on his budget from his client as far as what he wants to get done there. The sites can vary. If you have 160 acres, you do 10 sites. Less acres, you would do less sites, and that's all covered in the procedures manual as far as how many you need to do. Shallow bedrock, shallow water table, you need more deep drilling sites down to 3 meter to get a better idea of the distribution and depth. Soil and Essex soils, also more detailed sampling is required. The final report, depending in the irrigation districts, the final report needs to be at 1 to 5,000 scale. Outside of the irrigation districts, you can be up to 1 to 20,000. And the final report again consists of the map and report I showed you as well as the soils map. The ag feasibility reports are very similar. There's a few different guidelines as far as smaller size of parcel, but they follow essentially the same sampling guidelines there. Wastewater, similar but different. The classifications are different. For freshwater, you have classes 1 through 4 and class 5R could be irrigable. For wastewater, you only get classes 1 through 3. It's much more restrictive that way, as well as the depth of the water table and bedrock is more restrictive as well. And the mapping is a little bit different as well as a result of that. There's also additional samples that are required for wastewater to do with nutrients and whatnot, but that's not covered under the land classification guidelines. So briefly, who should be preparing reports? When we're looking at assigning or accrediting people to put on our list of classifiers, we're looking at people who obviously know soil science in general and classification in particular. Should have an ability to do soil and terrain mapping and some familiarity with assessment systems, you know, the standards and procedures documents, and should be, must be a professional hydrologist in good standing or an AIT working under a PA. I'm available to work with anybody who wants to learn more about that, and I've done that with a few different people as far as getting them up to speed on the standards and procedures documents and how to do all the work with this. As I mentioned, we do have a list of consultants. We will be asking them to sign a declaration attesting to they have the qualifications and whatnot. And when they're done, we ask that they provide us with their final reports, any logs, chemistry, soil location maps and whatnot to us. What we do with that information is we just warehouse it. This way anybody can come to us if they're looking for information. You'd be surprised at how many irrigation districts who should have this information provided to them still phone us and go, do you have information on this? And we're going, yeah, you should too, but they don't, so we're not quite sure how they do their filing in some of these places. But anyway, that's one of the reasons why it's good for us to have it. It's a central location because things get lost. And so what do? We used to do it all. Back when I started many years ago, the requests came from the farmer to the irrigation district to us, and then we went out, we did all the drilling, we did the field work, we did the chemical analysis, prepared the maps, mailed everything out and stored it away. Now that has been privatized. The actual preparation of the maps is all done by consultants, and that information is sent to us and stored in these nice filing cabinets. A lot of the work that I do now is talking with various people and clarifying the standards, explaining some of the work that we do, providing information, providing background to consultants, and again, just sort of looking at the standards and procedures and making sure that they're clear to those who need to interpret them. At this point in time, there's been approximately 12,000 quarters of land, or parts of quarters of land, covered within the province, and that extends all the way from Peace River down to the U.S. border and Saskatchewan to BC. So it's covered a lot of ground in its time. I've been fortunate enough to go to most of those areas, so it's been a good experience for me to see a lot of different areas of the province.